You are listening to Speaking Of by WFSU Public Media. Longleaf pines thrive with fire, and humans try to aid that with prescribed burns. But fire predates our use of it, leaving humans to try and mimic how fires once burned naturally. Diaz de Villegas talks with Dr. Gene Huffman, a dendrochronologist who is using tree stumps to extract some surprising information from the tree ring record about fires. This episode is from WFSU's newest podcast, Coast to Canopy, available in full on all platforms.
Hi, this is Diaz de Villegas, ecology producer for WFSU Public Media. Today, I delve into the world of tree rings and fire. If there's one experience North Floridians all share, it's the smell of smoke in the early spring. It comes from fires started, intentionally, by humans. But fire has been in Florida long before people arrived.
What we find in Florida is that fire was always present on the landscape.
This is Dr. Angelina Parati in a clip from WFSU's recent documentary, Finding the First Floridians. She studies pollen, fungus, and charcoal found in sediments. I interviewed her to learn about Florida's Ice Age landscape, to understand what it was like when people first arrived here at least 15,000 years ago. Back then, Florida was dominated by open, grassy landscapes filled with large herbivores such as bison and mammoths. And from time to time, it burned.
Prior to the decline of mega herbivores, those mega herbivores were reducing the vegetation enough that even when there were fires, maybe they weren't big enough or widespread enough to leave a big record in paleoecological archives. But after their extinction, we see a pretty significant increase in fire.
As Ice Age grasslands became modern longleaf pine savannas, fires burned more frequently. But how frequently? To answer this question, we look not to the sediments, but to those longleaf pine trees. My guest in the studio is Dr. Gene Huffman. She's a dendrochronologist with Tall Timbers Research Station in Tallahassee.
Dendrochronology, dendro means tree and chronology time, so it's looking at the records that are held within trees. But my work specifically does fire history, so that's my particular interest in dendrochronology is finding the history of past fires.
Gotcha. And so we have here between us in the studio on the table a couple of cross sections of, longleaf pine trees.
This one's a slash pine and this one's a longleaf pine.
Okay, yeah. And so, of course, when we talk about the record contained within trees, we're talking about tree rings, right? And so we can see the rings here. So describe what's the information contained within these rings? What are we looking at?
Okay, well, I'll start with this little one. And this is from the St. Joseph Bay State Buffer Preserve. And it only has about 12 rings. And I use it as a demonstration to show kids and other people what a tree ring is and how you can look at fire scars. So a tree ring consists of the early wood, which is light colored, a band of early wood, and then a band of late wood that's dark colored. So those together make one annual ring. And this section has a fire scar. It just happens to be from a fire that I did as the manager at the Buffer Preserve. I conducted a fire, and it happened to scar this tree. And you can tell two main things about fire history from these scars, and that is the year. So dendrochronology is the science of exact dating tree rings, and so it's not difficult in this one, because it has bark and you know when it was cut, and it only has a few rings. So that's easy as far as year, but you can also tell the timing, the seasonal timing of when a fire occurred by where the actual scar occurs within the ring. So this particular scar is at the end of the early wood, right before the late wood starts. I've done other research that assigns months to the position of the scar within the ring, and that means that this fire happened about in June.
Right. Yeah. And so you have a presentation you do, and I saw one of your slides you show. You kind of can go in a little bit closer, I guess. What do you use to look more closely at the tree ring? I say it almost looks like I can see the cells of the wood.
Right. Well, generally, for fire history, you have to take cross-sections of trees. And so most all of what I use are stumps, are old stumps. And what you have to do is take a cross-section and then surface it, sand it really finely so that you can actually look at it with a microscope. And when you look at it with a microscope, you do see the cellular structure, you know. When I first started out in tree rings, all the work was done with a microscope and a manual measuring stage. How you date these things is by measuring every ring and looking at the patterns of growth. So that used to be done manually with a measuring stage and a microscope. But in the last years, like most things, now there's a system that you can do it digitally. So I surface the cross sections and then scan them with a high resolution scanner. And then you can look at the rings on a computer screen and measure the rings digitally on the computer screen, which is a great advance in in ease of interpreting and dating these trees.
I bet. And then so I'm looking here and I see some of the dark bands are wider and some are narrower. So what does that tell us about those years, I guess?
The thing that makes us be able to use trees for historical records is the exact dating. And the exact dating is possible because trees respond to environmental factors across, a population. So in this case of the longleaf and slash pines, the environmental factor that the growth response is most tied to is rainfall. So in years where the rainfall is really low, you'll have a narrow ring, and where there's more rainfall, you'll have a wider ring. So that pattern of years and size of the ring is what allows us to make a growth chronology that allows dating of ones that don't have a known outer date.
Are there any other types of scars than just fire scars? So could you see if a hurricane hit or any other sort of weather event?
Yeah, anything that injures the cambium of a tree will cause a scar. So in my trees, sometimes there's a big area of cambium that's killed and wood removed, and that shows cat face scar from, when people were doing turpentine operations and cat facing the trees or scraping the bark off so that they could extract the resin. So there are human type scars like up north where indigenous people stripped bark for various reasons and things. So you can get human history, human injuries, you can get insect injuries. So if a bug gets under the bark and chomps the cambium a little bit, that will cause a scar. And then there are, of course, the fire scars. So when I'm looking at these, I do see other kinds of scars.
Gotcha. Another thing that kind of surprised me about your presentation was looking at tree rings to get a fire history has been done quite a bit in the country, but not a lot of the studies happen down here in the South where our ecosystems are the most fire dependent. Why is that?
Right. Well, when I started doing this work, which was about 1998, there were no fire histories whatsoever for the Southeast. And there are several reasons for this. One is that you need old trees that have recorded these. And because the Southeast coastal plain was logged so extensively, that there are very few old trees left. But the other thing is you can get this kind of information from stumps and dead trees, but in the Southeast, most stumps were removed. So the resin that's in the trees that they did for turpentining, it's also in the stumps. So in the 40s, and actually even now, wholesale removal of stumps across the landscape. So there's not an abundance of the fire-scarred material, the trees that you use to make fire history reconstructions. But the other thing is there haven't been a lot of people looking for it. There haven't been a lot of dendrochronologists here. Out west, there are literally, just hundreds and hundreds, maybe thousands of studies. Just a huge number, and also in the north and stuff. But the Southeast was a big gap. And another reason for this was that you could look at a cross-section of a stump or of a tree and there'd be no fire scars because longleaf pines are super fire resistant. And actually, if they do get an injury like a cat face or something like that, they tend to burn up and die because the resin on the face and all. So people weren't finding a lot of fire scars if anybody was looking. There weren't a lot of these external fire scars. It's where there's an injury and then the cambium starts to heal and it makes what I call a curl. It curls over trying to close up that injury. And every time the fire comes, that tissue is sensitive, and so it makes a scar. That's a lot of the fire histories that had been done up to that time were based on external scars. What was the real breakthrough for making fire history here in the Southeast was what I found after I did a first fire history was the Little St. George Island that had these external scars that were caused because of the previous cat facing, but it didn't go back very far. When I started collecting from old stumps at the buffer, my husband Neil, who does all this work with me, and I were able to sample some of these stumps all the way down to the ground. You know, they were turned up, and so we could sample them right at the base, right at the interface, like of the roots and the shoot, the bole of the tree. And what we found there was lots of fire scars. And that was the incredible discovery that has made all the subsequent old fire history reconstructions that go back far in time, is because we could find scars. Whereas if you sampled up, just, 6 inches up, there are no scars. But right there at the base, there were lots of scars. And that's because they're so fire resistant, the trees are, but things fall at the base, like pine cones, branches, lots of pine needles. So the intensity of the fire can be very hot in different places. And so that's why they have scars there when they don't have scars anywhere further up. So I think that had a lot to do with why there haven't been fire history reconstructions in the Southeast very much.
Yeah, and I guess during a prescribed fire, if you look at one, especially if the area's been burned a lot, fires aren't very tall to begin with.
Exactly.
So it makes sense to be lower down.
Exactly. And also the fact that there aren't scars, because fires are so frequent, there's very little fuel. So a fire up north in a type of habitat that burns every 30 or 40 years has very intense fires that do scar trees. Here, historically, the fires were so frequent that they don't get those high fuel accumulations that would have made scars.
Right. So you mentioned a little bit ago how much of longleaf habitat in the Southeast has been logged, and it's something like 90% of it is gone from the historic. Or is it even more than that?
I think it's like 99 and a part.
Right.
More than 99%.
And of course now people are trying to restore a bit of it in different places, and talk about, the importance of knowing this information that you can get from these stumps.
This is sort of my motivation for all of the research. So before I started doing this work, I did land management, and I'm a prescribed burner. And you realize that people set the agenda as to fire regimes now, in natural areas where fire is very important. We decide how often and what timing of the year, what season that fires occur. But what information do we have about it? Nobody took records before 1900 or so. And the big question was, what was the fire regime in the past? What were fire regimes like here? I and a lot of land managers, fire managers, are very curious as to how this area burned in the past, especially pre-European settlement. What were the fire regimes like? what I found with my first studies, like the little St. George Island, is that even though it was an island, fires were pretty frequent, but this was just, post 1860. But then for my dissertation work, I did a study at the St. Joseph Bay State Buffer Preserve, and there I had these old stumps, and I had just discovered the methodology that the scars were low, and so I only had 6 trees, but from those 6 trees, I could find out that the fires were, 1 to 3 year interval, and mostly in the growing season, at the transition season between the early wood and the late wood. Anyhow, that information, one of the things that makes me happy about doing this work is that it is useful to managers. So previous to that, FNA, which is the Florida Naturals Area Inventory, that kind of sets a standard of different habitats and how often they would have burned and all that. They had, I believe it was either a 2 or 3 to 5 year interval is what they thought it was. But after my research showed this, they actually changed the interval to 1 to 3.
Okay.
So it's like that made me very happy that this work has, some influence and application as we learn about these systems that it could help. But what's been really interesting is my most recent research that's at the Tyndall Air Force Base, near the Buffer Preserve. This is with my husband, Neil Jones, and Kevin Robertson, and Monica Rother, other people from Tall Timbers. We have collected many trees and sampled them low and have a really complete record. And we have been very, I have to say, surprised to find that the fire interval during the period from like the late 1500s to the late 1700s, even into the 1800s, was annual. Wow. The fire frequency was very, very, very frequent. And also it was mostly in the late spring, summer season.
Okay, so there's a few things there I want to follow up on. So seasonality, and then also just the age of the trees. But first, you talked about FNA had previously set a standard for burning every 3 to 5 years. And what happens after you get past 3 years or so of burning? Talk about what happens to an ecosystem the less fire is applied to it.
Well, it turns out that this 3-year threshold is very important. So looking at pine flatwoods, if fire is applied more than every 3 years, if you have gaps that go more than 3 years, it shifts towards woody dominance. So towards increased palmetto, gallberry, all kinds of woody species. And that's basically a 3-year tends to keep it at equilibrium. Less than 3 year makes it less woody, and more than 3 years, it gets woodier. And you can see this extremely clearly at the Tall Timbers fire plots, where they, for many decades, have burnt plots 1, 2, 3, 4, and more intervals that were set up by Herbert Stoddard at Tall Timbers in the, I think, 1950s or 60s. I think 60s. Anyhow, what they found doing this is that when it got over 3 years, it became so shrubby and so closed in that fire wouldn't really even carry anymore. It was only the 1 to 3 that maintained it at all, and the 3 was borderline. It's the 1 and 2 was what maintained these open, basically sort of grasslands or savannas, where you have this really diverse, beautiful ground cover of wildflowers and grasses. If your fire frequency went higher, you lose it, and it becomes a shrubby thicket.
So when you talk about woody growth, we're talking about longleaf pine trees are kind of widely spaced apart depending on, different settings. There's a lot of grasses and wildflowers and things growing between them, right? And some what we call woody shrubs, the hardwood trees, So these are oaks and other types of things like that, right?
Right. Historically, these areas burned frequently and they were open like you describe. But when fire is excluded, what moves in is like tree species that, like laurel oaks and water oaks, things that wouldn't survive a fire. So historically, they weren't in the system because they couldn't get established because of the frequent fire. So those things move in. And then the shrubs that are there naturally that are kept low by frequent fire just explode. So it gets full of hardwood tree species and shrubs that weren't there originally. It basically results in the loss of the ecosystem, loss of the wildlife of things like gopher tortoises and bobwhite quail, which was the focus of Tall Timber's research that really brought to light how important fire was to maintain these ecosystems, the plants and the animals.
And so there's a lot of restoration that's going on right now in the Panhandle and throughout the Southeast, but I know there's various projects I've covered, and sort of a goal of that would be to get to something kind of like how it was before. And to know that, I guess you need to find some of these older tree stumps and talk about not only just finding older trees, but building, I guess, a key for an area, going back even further so you know how was fire then.
Yeah, actually, the first study that I did was, like I said, the trees on Little St. George Island that were 1850s onward. But the second site was the buffer preserve, which was stumps. And these stumps, because of the previous stumping across the landscape, they're quite rare, So it was an amazing discovery to find these. But of course, we didn't know how old they were because nobody had worked with them before or dated them. That was the focus of my research, was to make a growth ring chronology that started in the present and went back, a pattern of narrow and wide rings that I could use to date these unknown stumps. And what we found is they dated to the 1500s, 1540, 1530 for the oldest ones, and only went up to the early 1800s. So these stumps, and some of the stumps, the outer date is like the 1700s, so that the stumps, especially in trees that were cut, trees that were cut by people, the tree does some kind of process that makes the stumps full of resin, like sort of like concrete, and they really persist for hundreds of years in the right conditions. The buffer study kind of brought the fire history work back to the 1500s right away.
The conversation continues on WFSU's Ecology Podcast, Coast to Canopy. Look for it wherever you find podcasts. And for the illustrated version of the story, with photos and links to other longleaf pine content, visit wfsu.org/ecologyblog.